In this class, we will solve some problems, examination problems, video question paper problems. The first problem is like this. It is given in July 2022 question paper. Determine the force F and its inclination alpha required so as to lift a block of weight 500 Newton. So this is the diagram. This is the block. This block of the weight of the block is 500 Newton. So we have to lift this block. So in this direction. So lifting we have to do in this direction. So there are two forces applied to lift the block. One force is given 120 Newton at an angle of 30 degree with the vertical. Another force is F, which is unknown, at an angle alpha with the vertical. So now we have to find out the value of this F and alpha so that the block is lifted upwards. That means in order to lift the block upwards, it is like this. So this is the block. Since the weight of the block is given as 500 Newton, so it has to be lifted with a resultant force of 500 Newton, which is acting in the opposite direction. So now here this force 120 Newton force and also the force F, they have to be resolved. So if I resolve this 120 Newton force in two equally perpendicular directions like this, so this angle is given as 30 degree. So this force and this force. So since this is 30, this becomes cos. So 120 cos 30, and this is 120 sin 30. Or you can take this as 60 degree and you can write as 120 cos 60 and 120 sin 60. They are same. Similarly, if I resolve this force F, force F is acting at an angle of alpha with the vertical direction. Here, if you resolve this, this becomes F cos alpha, this becomes F sin alpha. So please note that here the block is lifted upward. That means the resultant also should be in the upward direction, positive y direction, and there is no movement in the x direction. So that means in this case, the thing is your sigma fx will be 0. X component of the resultant, that is Rx, which is sigma fx, it will be 0. I will take here the sign convention for the force towards right, positive, left, negative. Now if you take the forces in x direction, 120 sin 30 is acting towards right, F sin alpha is acting towards left. So therefore, I can write the equation 120 sin alpha, sin 30 degree, minus F sin alpha is equal to 0. This is the equation we are going to get. From this we can write F sin alpha is equal to 120 sin 30 is 60. So this is one equation we can get by using the first condition that since the block is lifted upwards, resultant should act in the upward direction, that is in y direction. So therefore there is no force along the x direction. Now the second thing is, since W is acting downwards, so sigma Fy, if I write, that sigma Fy can also be written as Ry. That is the y component of the resultant. So if you use this diagram, so here this is also positive, this is also positive, and okay, 120 cos 30 is positive, F cos alpha is positive, but this 500 Newton is negative. That means I can write this as 120 cos 30 plus F cos alpha minus 500. So this is the alternate sum of the forces in the y direction, treating upward positive, downward negative. Okay, this is how we have to take. Now from this we can write here, this should be equal to 50, is it right? So because this should be minus 500. So I have taken this as is equal to 120 cos 30, okay, only 120 cos 30 is this one, F cos alpha is this one, that should be equal to 500. Yeah, that should be equal to 500. So this is what we can take. That means in this case, sigma Fy itself is equal to Ry, that itself is equal to R. Now from this equation, you get F cos alpha is equal to 500 minus 120 cos alpha. So if you simplify this, so you will be getting the value as 500 minus 120 into cos 30, which is 396.1 you are going to get. So that means F cos alpha is equal to 396.1. Now you have two equations. Use this all by solving these two equations. You can get the values of F and alpha. What I will do here is I will divide equation 1 by equation 2. So you will be getting F sin alpha, LHS and LHS terms will be divided. Divide by F cos alpha is equal to 60 divided by 396.1. Or you can write it as tan alpha is equal to 60 divided by 396.1, which is 0.1515. Alpha is equal to tan inverse of 0.1515, which is 8.61 degrees. 8.61 degrees. That is the value of angle alpha. If you want to find the value of F, so substitute for alpha in one of the equations. I will take first equation. F into sin alpha is 8.61 degree is equal to 60, or you can write F as 60 divided by sin 8.61 degree. 60 divided by sin 8.61, which is 400.78 newtons. So this is the force with which the block has to be pulled in this direction so that the block is lifted in the vertical direction. Of course, this is a simple problem. Two unknowns will be there. It's a case of coplanar concurrent force system. So whenever you have the resultant given in one of the direction of resultant is fixed and its magnitude is fixed, then definitely you can find out the values of the unknowns, force and angle, by using the equations of equilibrium, or you can write you cannot say that this equation of equilibrium by equating sigma fx to the horizontal component of the resultant, that is x component of the resultant, and by equating the sigma fy to y component of the resultant, you can find out the required unknowns. This is one problem. The second problem from the same question paper. Second problem is like this. So he has given a diagram like this. See, this is the diagram. This is the axis, center line. A, B, C. So he has taken this is O. This is point O. This is B. This is A. So he has given the distances 100 mm. That is OB is 100 mm. BA is 150 mm. 150 mm. He has given this angle as 20 degrees. He has given a force here 500 Newton force, and this 500 Newton force is making angle alpha with the BA, 9 BA. Now the question here is determine the angle alpha, or find the angle alpha for which the moment of 500 Newton force is maximum at point O is maximum. Moment is maximum at point O. Also find the maximum moment. Also find the maximum moment. So it's a different, of course, different type of problem. So you can see here there are two. This is a bent up bar. OB is 100 mm, BA is 150 mm. A force of 500 Newton is acting at A, and the angle is not known. We have to find the angle alpha so that the moment due to this 500 Newton force about the point O should be maximum. So maximum moment should be there. That means what you can see here is MO is maximum. Moment at O should be maximum due to this 500 Newton force. Of course, only one force is given here. And then later on we have to find out, after finding alpha, we have to find out the maximum moment value also. So the solution runs like this. Let us first find out the moment of that, the expression for the moment of that 500 Newton force about the point O. So for that, what I do here is, so this is the point O. Now this is the distance. That is the point where that 500 Newton force is acting. Now what I will do here is, I will resolve this force into two components. One component I will take like this. Another component I will take like this. Okay. Otherwise, that angle is alpha. So we need to find the value of alpha here. So, okay, I will do one thing. This OB you know, BA you know, this is 20 degrees. That means let us find out this distance now. This distance will be, if you calculate that, this distance. So if I take this as C, AC will be AB sin 20. Okay, and AB is 150 into sin 20 degree, which is 51.3 mm. 51.3 mm. Similarly, the distance BC is nothing but in this triangle. This is this right angle triangle. In this becomes 150 cos 20. So 150 into cos 20 degree. So that is 140.95. This distance is 140.95 km. Okay. That means if you try to resolve this 500 Newton force into two components, then we can write down the moment expression. So moment of this 500 Newton force about the point O is nothing but moment due to this horizontal component plus moment due to this vertical component. You can see that both the moments are clockwise. So this force is giving clockwise, this force is also giving clockwise moment. I will do one thing. This okay, what I do here is, let me resolve this force in two directions. So be careful here. In two directions. One direction I will take like this. Another direction perpendicular to this. Like this. So I will write it separately here. 500 Newton force is given like this. It is acting at A. So this is AB. So here, this angle he has given as alpha. We have to find out the value of alpha. What I do here is, I will resolve one force like this, another force like this, so that this is 90 degrees. The angle between these two is 90 degrees. So this becomes 500 cos alpha. This becomes 500 sin alpha. like this. So this is the diagram. Now I have to write the moment of this and moment of this. So of course both are giving clockwise moment. So sigma mo is nothing but it is giving clockwise moment, which I will take as positive. Moment of this if I want to write, that is 500 cos alpha, that is the magnitude of the force, multiplied by the distance. So distance for this is this distance. So this is the distance. So you should be careful here. So this is the line of action. So this is the line of action. So for that I need to find this distance. So that distance becomes now, if you find this one, so if you want to find that one, you have to take this triangle. So be careful here. A, B, not B, I will take this as D, A, D, this is O. Of course, this is right angle triangle, see here. So I have to take a triangle like this. If I take a triangle like this, then I can find out this OD distance. So here, if you want to find this OD distance, I need this distance also. I need this distance also, and that means this value. I need this distance as well as this distance. So here this is known, but we have to think whether we can find out this or not. Okay. So here, okay, let me cover this in the next lecture.